Hello, this video is a review for logarithmic function and the graph. Okay, so first of all, what is log? What is log? Okay, log. If I say 2 to the power 3 equals, no, well, 2 to the power 3 equal 8. Okay, so the log just another way to represent exponential, represent power. So you switch 3 and 8. We say log with base 2, 8 equal 3. Okay, so this means 2 to the power 3 equal 8. Okay, so well, what I to find, for example, I want to find 60 log base 4, 64 equal x. So what I should think is 4 to the what power equal 64. Or first of all, you have to change into the format you're familiar with. So you can write 4 to the power x equal 64. And because 4 cubed equal 64. So x equal 3. Right? Yeah. Give another example is 3 to the power 4 is 81. So that's why log base 8, base 3, base, this is called, we call base 81 equals 4. Okay, how about the functions? So the functions, let me draw a function. Okay, maybe a new one. Okay. So y equal log x. Okay, I suggest you when you do the practice, use decimal to help you to find the transformation. Okay, this is the basic log function graph. So let's come back to here. Okay, so we come back to OneNote. All right. So what about domain, range, and behavior, intercept, and asymptote for this graph? Okay, domain is for left and right. You see there's the whole graph is on the right-hand side of y-axis. This is y-axis. Also can say that this is y equals 0. So domain, the whole graph is on the right-hand side of x equals 0. That means x can only be greater than 0, cannot be 0. Okay, and range, because your y can be any value. Okay, so there's no limit for y. So it's all real number. For m behavior, this graph will keep going up. So when x approaching infinity, f of x approaching infinity. But I cannot write x approaching negative infinity because we know x can only be greater than 0. So there's x cannot be negative. So I can only say x approaching 0, your f of x. So you see, when x approaching 0, which means approaching this yellow vertical line, the value of y keep decreasing. Let me say again, when x approaching this x equals 0, the value of y, the y coordinate, keep decreasing. So that's why f of x approaching negative infinity. Intercept, okay, intercept. So you plug in x equals 0 to find y-intercept. You plug in y equals 0 to find x-intercept. Okay, so if x equals 0, so y equal log 0. Okay, if you see the log without base, means base is 10. Base is 10. Okay. By the way, do you know how to type log? If you don't know how to type log on TI-84, come to me, okay? Basically, use math and you scroll down. There's an option called log base. Again, use math and go down, found log base. Okay, that option you can type. So how to solve this? How to find this is when x equals 0. Okay, x equals 0. So that means log base 10, 0 equal y. So we convert to the way we like. That's 10 to the power y equals 0. That is impossible. Impossible. No matter what y is, there's no such y make this 0. So it cannot be 0. So there's no y-intercept. There is no y-intercept because when you plug in x equals 0, no solution for y means no intercept between the function and y-axis. And then you plug in y equals 0 to find x. Find equals y equals 0 to find x intercept. So that 0 equals log base 10x, okay, equals 0. And then you convert to the way we're familiar with. That would be 10 to the power 0 equal x. There is a such x exists, x equals 1. So the intercept, you see the graph here, the intercept is, use the red one, is 1, 0, because when y equals 0, x equals 1. In fact, no matter what base what a base is, like base 2, base 3x, okay, base, so it will always go through 1, 0, even is less than 1. So let me go to the graph. Okay, so I have you y equals if I use log functions, log. So I said 2, okay, 2. Okay, so the red graph is base 10. Base, we use 10 for base. The blue graph we use 2 for base, but they both go through the point called 1, 0. How about we use another one we use base 3? Oh, wait. We use 32. Okay, so always goes through 1, 0. Okay, even when I change the base to the number between 1 and 0, maybe this is 0.32. Okay, remember, if this number, the base is between 1 and 0, the graph look like upside down. Okay, from if your base is maybe 0.5x, the base is between 1 and 0, it still goes through 1, 0, but your graph will become like this. Okay. And what the difference? One of the end behavior, okay, when x approaching 0, and then f(x) approaching infinity. When x approaching infinity, f(x) equals 0. So you need, if this number, the base is between 1 and 0, the end behavior must switch. Okay. And this is the intercept, but the intercept remain the same, always 1, 0 for this. All right, what is the asymptote? Asymptote. So let's go back to here. Asymptote, so we come back here. Asymptote is a straight line. Okay. Okay. So asymptote is a usually not always, but usually asymptote is a vertical or horizontal straight line. So for example, this vertical line we call asymptote. Because the red graph will keep approaching this vertical straight line, keep approaching, but never touches. So we call asymptote. And the name of the asymptote is x equals 0. Actually, is y-axis. Y-axis. All right. So let's have a look at the sheet I give you. This one, the question 23. What are the differences? Okay. The question 23 is f of x equal log. There's no base, means base 10. Okay. X minus 1 and then plus 1. This minus 1 means shift to the right 1 unit. This plus 1 means shift up 1 unit. So because I know the graph of the parent function must go through 1, 0. 1, 0. So I will shift this point right 1 unit. So from 1, 0, shift 1 unit to the right and then 1 unit up. Goes to 2, 1. Okay, 2, 1. And the new graph look like this. Actually, you don't have to do that. You just use a calculator to do it. How about domain? Okay, domain. Because you see the domain for parent function is x greater than 0, but since the graph shift to the right 1 unit, so the new domain is x greater than 1. X greater than 1. Cannot be 1. Okay. Range is about vertical, up and down. But the range for parent function is all real number. So no matter how much you shift up or down, it doesn't matter. It will not affect the range. So the range is still all real number, because your y can be any value. Can be positive here, can be negative. Positive for y means above x-axis. Negative for y means under x-axis. Okay, both can be above or under axis, the graph. Okay, and behavior x approaching infinity, f of x still approaching infinity, because here it's going up, right? When x approaching, can I say approaching 0? No, because your x must greater than 1. So I can only approaching 1, which is this vertical line called x equal 1. When x approaching that value, y keep decreasing, so that f(x) approaching negative infinity. And then you plug in, I can see that there's no intercept with the graph and the y-axis, so there's only x-intercept. For x-intercept, I plug in y equals 0 to find x-intercept into this function. X-intercept. So how can we solve that? Y equals 0. So log base 10 x minus 1, and then plus 1 equal y equals 0. Okay, so I move positive 1 to here, so become log base 10 x minus 1 equal negative 1. Okay, next step, I convert log into the way we like it. So that would be 10 to the power negative 1. 10 to the power negative 1 equal what? Equal this, equal x minus 1. All right, what is 10 to the power negative 1? That will be 1 over 10 equal x minus 1. So x equal 1 plus 1 over 10, that's 1.1. Okay, so the intercept will be 1.10. That's your y-intercept, 1.1 and 0. Are you sure? If you're not sure, go to Dasmos. All right. So what is my function? Is x minus 1. And then plus 1. And then you see the x-intercept is 1.10. Yeah. All right. Lastly, what is asymptote? Asymptote, because the asymptote for the original, the parent function is x equals 0, but the whole graph shifts to the right 1 unit. So the asymptote for the parent function is, can I write x equals 0? Okay, x equals 0 is this black one. That's this black line. I don't want x black one. Is that no any color? Can I change the color? Shoot. Anyway, can you see it? Okay, this black line is x equals 0. It's the asymptote for the parent function, but we shift to the right 1 unit, so x equals 1. So this is the new asymptote. Okay, you see the red graph is keep approaching to this line, but never touches. All right. So the asymptote, new asymptote is x equal 1. All right, that's it. If you have any questions, let me know. Okay, good luck for the test. This is for log. See you next time.